Okay, in this video, we want to evaluate inverse trig functions, and we'll solve three problems. This is problem 1, problem 2, and problem 3. Now, in order to solve inverse trig functions, we're going to have to combine a lot of the reference video that we just created. So the first step is, how can we get square root of 2 divided by 2? And so we'll use this reference table. The way we can get the square root of 2 divided by 2 would be for sine pi over 4. So what value of sine would give us this? So that's going to be sine pi over 4 would give us the square root of 2 divided by 2. The next thing is to look at our inverse trig functions reference table. And so the only angles that we can choose will be from negative pi over 2 to pi over 2. So this is where we're restricted. We could be here or we could be here. And so the last step is, where is negative and where is positive? So we know all students take calculus. So all sine is positive, cosine is positive, tan is positive. So this is a positive. And here, calculus, only cosine is positive. So sine is negative. And since we have a negative in the front, we will take negative pi over 4. So just to recap. First, I need to know, how can I get this term right here? What value of sine would give us square root of 2 divided by 2? And the value of sine would be pi over 4. Sine pi over 4 would give us the square root of 2 divided by 2. The next step we need to do is our reference restriction. So for inverse sine, the only thing that we can choose is negative pi over 2 to pi over 2. That's a rule. So we can either be here or here. And then finally, the third thing we need to consider is which is negative and which is positive. And so that's why we were able to conclude that the answer would be here, which is negative pi over 4. Because sine negative pi over 4 would in fact give us negative square root of 2 divided by 2. And that's how we concluded that sine inverse negative square root of 2 divided by 2, the answer would be negative pi over 4. And so we do the exact same approach for this one also. So we have cosine inverse negative square root of 2 divided by 2. So we need to think, how can we get square root of 2 divided by 2? What value of cosine would give us square root of 2 divided by 2? And so this is something we need to have memorized, this table. Traditionally, you will solve inverse functions for these angles. And so we have square root of 2 divided by 2. So that's going to be cosine pi over 4. So pi over 4 would give us square root of 2 divided by 2. The next step is to say, what is our restriction for cosine inverse? So using this table, we know we can only choose angles in the interval of 0 to pi. So 0 to pi. So we're only going to look from here to here. And we know that this first quadrant is positive for everything. Positive for sine, positive for cosine, positive for tan, so positive. But this quadrant right here is only positive for sine. It's negative for cosine, so negative. And since we have a negative square root of 2 divided by 2, we will choose this one right here. So we know pi over 4 is going to be here, and so we want the angle here. And so we will do pi minus pi over 4, which will give us 3 pi over 4, and we will be in this quadrant. And that's why the answer is it. And the last question is tan inverse, parentheses, negative square root of 3. So how can we get square root of 3 for tan? So we know that tan pi over 3 would give us square root of 3. So that's why you say pi over 3. And next, we need to know what angles can we choose for inverse. So for tan, we can only choose negative pi over 2 to pi over 2. And so the next step is to know where is positive and where is negative. So first quadrant is positive for sine, cosine, tangent. So we say positive. And the fourth quadrant, because we're going from here to here, this quadrant is negative because only positive for cosine. And since we have a negative square root of 3, we will say our answer would be negative pi over 3. And that's all we need to do to solve inverse trig functions.